Hello, what's up YouTube? In this video, I will implement the queue data structure using the linked list in Python. By the end of this video, you will feel comfortable using the queue data structure. Let's jump right into it. Before writing the code, let's understand the queue abstract data type and its operations. A queue is a collection in which the entities are kept in order, and the operations on the collection are the addition of entities to the rear end known as enqueue and the removal of entities from the front end known as dequeue. This makes the queue a first in first out data structure. In a FIFO data structure, the first element added to the queue will be the first one to be removed. Theoretically, one characteristic of a queue is that it does not have a specific capacity, regardless of how many elements are already contained. A new element can always be added. It can also be empty, at which point removing an element will be impossible until a new element has been added again. Check it out this article on the Wikipedia. These are the methods and attributes of a queue class which we will implement on our own. First is the queue class itself. We will use it as constructor to define multiple objects of queue. Next is the enqueue function. It adds new item to the rear of the queue and returns nothing. Next one is the dequeue. It removes the front item from the queue. It needs no parameter and returns item. The queue is modified. Next one is the empty. It checks whether the queue is empty or not. Similarly, the size. It will tell the size of the queue or the number of nodes inside. Another one is the front. It returns the data of the front node, and the rear, similarly, it tells the data of the last node, which this is the graphical representation of the queue. As represented, the deletion happen at the front end and the insertion happen at the rear end. These are the nodes pointing to each other: 10, 20, 30, 40. The first node is pointed by the front variable and the last node is pointed by the rear variable. Now let's define the queue class. First, it will require the node class also. So let's define it first. In its init function, it will have two parameters: the self, first the self, and next one is the data. Using the self, first let us define the data variable which will hold the data from the parameter value. Next is the self.next. Initialize to none, means at first it will point to nothing. Now let's implement the queue class and its init function. It will require only self variable. Using the self, let's define the front, which initialized to none. Next is the rear variable, which is also initialized to none. Now let's define the enqueue function. It will require two parameters, self and the data. Let's first check whether the queue is empty or not. It can be done by the following line of code. If self.rear is none, self.rear is none means the queue is empty. In this case, we will initialize both self.front and self.rear to a newly created node, and it's so obvious, like first created node is the first and the last in itself, so both variables will be pointing to the newly created node, and as it can be seen in the diagram also. If that's not the case, the self.rear.next means we are inserting the node at the rear end, so the rear end next pointer must point to the newly created node. After that, the newly created node should be the rear in itself. After attaching to the queue, Now let's define the dequeue function. It requires only the self attribute, and let's check whether the queue is empty or not. Here also it can also be checked by the following line of code. If self dot front is none, it means the front is pointing to nothing, means the queue is empty. In this case, let's return the queue is empty. If that's not the case, first let's capture the value which we want to delete in a variable called toReturn. After that, let's make the front point to the just next node after the one which we want to delete, so that the second one will be the first after deletion. After that, let's return the value which we have deleted and also we captured into the toReturn variable. Now let's define some simple remaining functions. First is the isEmpty function. It will return boolean values either true or false depending whether the queue is empty or not, and the statement in the return, that is self.front is none, it will give either the true or false depending like there is some element in the queue or not. The next one is the size function. It will require self attribute. First, let's initialize a variable. First initialize a variable count to be 0 and copy the self.front value into the current temporary variable. Now let's create a while loop. As long as there is some value in the current, this will keep on going. In the while loop, let's increment count by 1 as well as the current variable, that is CUR, increment by its next values. And then return the count value. The next function is the front. It returns the data of the node which is at the front position. It can simply return self.front.data. Next one similarly is the rear function. It will return the data at the rear node, that is the last node. Now the implementation is complete. Let's check whether the code works or not. Let's run the code. First, make a queue object using the queue class, and after that, first put some data using the enqueue function into the queue object. Let's check whether the queue is empty or not using isEmpty function, and it returns false, which means the queue is not empty. Next is the size method of the queue. It returns 4, that means it has the 4 nodes inside. Next one is the front. It will return the data at the front node, and similarly the rear function, it returns the data at the last node. And again the dequeue, it deletes the firstly inserted element first, like 1, 2, 3, 4, and now the queue is empty. That means there is nothing in the queue at this point. That's it. Thank you for watching. If you like this video, please hit like, and the link to this Python notebook is in the description section. Please check it out. Thank you so much.